welcome to True Projects. In this video, we are going to explain about the project that is a lesion-based diabetic retinopathy detection through hybrid deep learning model. Before getting into the execution, first let us understand what is the project about. So, diabetic retinopathy, it is basically an eye condition that happens when diabetes starts affecting the small blood vessels in the retina. So, think of retina as the camera sensor of your eye and it captures what you see and send it to your brain. When diabetes, it messes with the tiny blood vessels there, it can cause serious problems, leading to vision loss and even blindness if it is left untreated. And now the big issue is this diabetes is on the rise globally, which means more and more people are at risk of developing diabetic retinopathy. That's why early detection is super important. Catching it early can help prevent severe damage. So this diabetic retinopathy, that is DR, it doesn't just happen all at once. It progresses through different stages. The early stage is called non-proliferative diabetic retinopathy, that is NPDR. So this is when blood vessels start getting weak, leaking blood and the other fluids into the retina. It is like small cracks forming in a pipe, and if it is left unchecked, it gets worse. Then comes proliferative diabetic retinopathy, that is called as PDR, which is an advanced stage. So here the body tries to compensate by growing new blood vessels, but they are weak and abnormal, making things even worse by blocking vision and causing more complications. So doctors diagnose. So doctors they diagnose diabetic retinopathy by examining retinal fundus images. But this process is time consuming, it is resource intensive and it is prone to human error since it relies on ophthalmologists manually analyzing the images. This makes early detection difficult, especially with the increasing number of diabetic cases. And while machine learning has been explored as a solution for automated diabetic retinopathy detection, aiming to improve efficiency and accuracy, however, the existing approaches they often fail to extract critical retinal features such as microneurons, hemorrhages, and vascular abnormalities, leading to suboptimal classification performance. Without effectively identifying these key indicators, machine learning models struggle to provide reliable diagnosis. So, addressing these challenges is essential for developing an efficient, accurate, and scalable solution for early DR detection. Enhancing feature extraction can significantly reduce diagnostic errors, speeding up the detection process, and enable timely medical intervention, ultimately helping prevent that severe vision loss. So this project's idea is to detect diabetic retinopathy using hybrid deep learning model. Instead of relying on one single model, here in this project, we are combining GoogleNet and ResNet to extract important features from the retinal images. So these models, they are great at recognizing patterns. So together they do a better job for identifying abnormalities in the eye. Now, once these features are extracted, they need to be refined to make sure that most important ones are used. So that's where adaptive particle swarm optimization comes in. So here we are using APSO. Think of it as a smart filtering process that picks out the most useful features, helping the model to focus only on what really matters for detecting diabetic retinopathy. After refining the features, after refining the features using APSO, here we will be using multiple machine learning models. So the refined features are fed into the machine learning models like random forest, support vector machine, decision tree, naive Bayes, etc. Each of these models they work differently in classifying diabetic retinopathy into different severity levels, that is mild, moderate, and severe. So by using multiple classifiers, the system ensures better accuracy and reliability. And here, the biggest advantage is that the model improves lesion detection by focusing on both the early stage and severe stage features. This means the system is designed to catch diabetic retinopathy in initial stages, preventing vision loss while also being effective at identifying advanced cases. And all the models that are built in this project for classifying diabetic retinopathy are evaluated using accuracy, precision, recall, and FN score, which measures how well it classifies different levels of diabetic retinopathy. And the goal is to make detection faster, more accurate, and more reliable, reducing dependency on manual diagnosis. And to further improve the performance, here we have added some extension. So here we have incorporated exception model as the extension, which is known for its strong feature extraction capabilities. So by integrating it with the machine learning approach, the system improves how well it analyzes the data set, leading to better classification performance for different stages of diabetic retinopathy. And additionally, we have also added detection mechanism. That means we will be localizing and identifying where is that tissue damage for classifying a image to be diabetic retinopathy. I mean, which stage it is. So we have added detection mechanism using YOLO family that has been added. So YOLO, it is you only look once. It is a powerful object detection model that allows the system to precisely locate abnormalities in retinal images. This means it doesn't just classify an image but also highlights the affected regions, making diagnosis more efficient. And furthermore, we have developed front end of this project by using Flash framework. So this provides an interactive interface where users like medical professionals or researchers they can upload retinal images, view results, and also analyze findings. User authentication is also included to ensure secure access, making the system reliable for practical use in diabetic retinopathy detection and research. So this is the extension part. Now moving on to the implementation of this project, we have followed the steps mentioned in the flow of work. So here we have followed some set of steps for classification and the other set of steps for detection. So first, let's see what are the steps followed for classification. So coming to classification, first we have loaded the necessary libraries for image processing, model training and evaluation. Then comes exploratory data analysis part. So here we analyze diabetic retinopathy dataset to understand image distribution and characteristics. Then comes image processing part. Here we have applied transformations like rescaling, shear transformation, zooming, flipping and reshaping to enhance the training diversity. Then we have extracted features using two models, that is the proposed model GoogleNet and ResNet. That is combining GoogleNet and ResNet. We have extracted the features, and also we have used exception model, that is the extension to this project. So we have used this both models to select the to extract the important features. And then comes feature selection. So here we have optimized the extracted features using adaptive particle swarm optimization, that is APSO, for better model performance. And then comes defining the early stopping. So here we implement early stopping to prevent overfitting or underfitting during training. And then comes calling the model. So here we load and configure the deep learning model. Then comes building and training the model. So here we train the model using pre-processed images and extracted features. After that, we save the best performing model for classifying diabetic retinopathy abnormalities for further use. Moving on to the detection, similar to classification, here also we import necessary libraries and then comes exploratory data analysis part. So here we will be loading the images, we visualize them and analyze the variations. Then comes image processing where we convert images to blob objects, we define object classes, we declare bounding boxes and convert arrays to NumPy array. Then comes loading pre-trained model. So here we will be reading YOLO network layers and extract it output layer for feature detection. Then comes further image processing. So here we will be performing BGR to RGB conversion. We create segmentation mask and also we resize the image. And then coming to the data augmentation part. So here we apply randomization, rotation and transformations to make detection more robust. And then comes processing the data based on YOLO. So here we prepare the data in a format suitable for YOLO based object detection and we build the model. So here we construct the deep learning model for detecting retinal abnormalities. And then we train the YOLO model on the processed data set to improve detection accuracy. And then we save the best performing YOLO version for future abnormality detection. So this is the detection part. And now moving on to the front end. So here we have used Flash framework. We have built front end using Flash framework, which is integrated with user authentication, that is registration and login using SQLite. And here in the front end users, they can upload images for classification. They can upload images for classification and detection. And that image will be pre-processed at the backend for classifying and detecting. And that will be fed to the train model. Finally, outcome will be displayed through the front end of the application. So this is how we have implemented. Now moving on to the algorithms used. So these are the two algorithms used for feature extraction. This is the proposed model and this is the extension model. And here these are the classification algorithms used in this project for classifying diabetic retinopathy. So all these models, they are individually trained on the features extracted using GoogleNet plus ResNet and individually for exception model where features are extracted using this model. And this detection part is the extension. So these are the extension algorithms which are used for detecting the diabetic retinopathy. And to implement this project, we need basic requirements, which are hardware and software. So coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview. Now let's get into the execution. To execute, we are supposed to open the code folder that contains source code files. So these are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? So here in this folder, we have the dataset that is used in this project. So let's open the colored images folder. So these are the different levels. So here in this mild folder, we have the images of the diabetic retinopathy where it is of mild stage. It is at initial stage. And here in this, we have images of diabetic retinopathy where it is at moderate stage. And here, where these are the eye images, these are the retinal images where there is no diabetic retinopathy. And here, this is the proliferative stage. This is the proliferative stage. And this is the, here in this folder, we have severe stage images. And these are split into two subfolders, that is train and validation. So images which are in train folder will be used for training and validation folder for evaluating the model. So let's get back. And images which are in these folders, they are used for classification purpose. So here we will be using specifically these images for classifying to just say whether which stage that retinal images, that is whether it is mild, moderate or anything. Let's get back. And here in the sample folder, we have the images that we will be using in the front end for doing testing. And coming to static folder, so here in this folder, we have files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And coming to the templates folder, this folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here in the YOLO folder, we have the dataset used for detection purpose. So the images which are in this folder are used for detection. And they are split into train and validation. Let's open train folder first. So here we have two subfolders. One is images and the other one is labels. In this folder, we have images and annotation files we have in labels folder. So first, let's open images folder. So these are the images that are used for training the model, that is the YOLO model for detection purpose. Let's get back. And annotation files, that means the locating that diabetic retinopathy, that locations we will be having in this label folder. So let's open this label folder. Here we have annotations and the labels for objects in the corresponding images. Here, each YOLO file, it corresponds to an image file in the image folder. For example, the first annotation file, it corresponds to the first image file. So it corresponds to this image. Similarly, for the second image, we have second annotation file. Accordingly, for all the images which we have in images folder, so for all the 1428 images, we have annotation files. So here we have total 1428 annotation files. And here all the YOLO files, all the annotation files, they follow the YOLO format. So let's open a file for sample. So here this line represents a detected object. It is followed by object class index and it is followed by bounding box coordinates. So this is the object class index and this is the x limit, this is the y limit, this is the width and this is the height. Similarly, we will be having in all the annotation files. Let's get back. So images which are in train folder are used to train model and images which are in validation folder are used to evaluate the model. And here images which are in this folder are used for detection and images which are in this folder are used for classification purpose. And this is the app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And this is a model file. So this file contains the algorithm information and this will be loaded into the project code during runtime of the application. And here these are the two Jupyter Notebook files. So these are the two Jupyter Notebook files which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. So coming to the classification Jupyter source file, here we will be using all the models to classify the diabetic retinopathy, and this Jupyter Notebook file is used for detecting the diabetic retinopathy. And here these are the model files. So these are the model files. And the last file is the database file. So this is the database file. And this is the model file. So this is all about the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open Anaconda prompt. So here it is open. Give the command cd, give the space and paste the copied path. Now click on enter. Here you can observe, right? Current directory is changed to the code folder's path. Now compile app.py file. So by giving the command app.py, now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. Just wait for a while. File is being compiled. So now copy this local link. So here application has been hosted at the local host and the port unless configured differently. So now copy this local link provided by the Flask framework. So copy it and paste it in any web browser. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. So this is the web page of the project which is displayed in the browser and this is developed using Flask framework. So now we need to get signed up. First click on sign up and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on sign in. Give your username and the password. Click on sign in. We have signed in successfully and we are redirected to classification page of the project. So here we will be doing classification and the detection. So first let's do classification. Click on classification. And here you can see a choose file button, right? We need to click on that for uploading the images. So let's click on choose file. Open the sample folder. Here we have two subfolders. So as we're doing classification, let's open classification. Now let's upload images which are in the mild folder and let's see whether application will predict correctly or not. So let's upload first image. Click on open and now upload it. So the given image, it will be pre-processed at the backend. It will be fed with the train model and then train model will be giving us a prediction. So here you can observe, right? The application has given, it has predicted correctly that this retina, that means this eye is being affected with the mild diabetic retinopathy. So here you can observe it in the blue color text. Let's get back. Click on choose file. So now let's upload this folder images. So let's upload this one. Click on upload. And here you can observe, right? It is predicted as moderate diabetic retinopathy. It is being predicted correctly. So click on choose file. So now let's open NodeR. Let's upload this one and click on upload. So here we got the prediction that there is no diabetic retinopathy. So here we can observe that there is no diabetic retinopathy. So now let's upload images. Click on choose file. So now let's upload images from proliferative diabetic retinopathy folder. So now let's upload this one. And here we got the prediction that it is predicted as proliferative diabetic retinopathy. So here, this person is being affected with the proliferative diabetic retinopathy stage. So he is at proliferative stage. And let's upload images from the last folder, that is severe folder. Let's upload this one. And here we got the prediction. So here, person is at severe stage. So he has diabetic retinopathy and he is at severe stage. So here you can observe, right? When we have uploaded the image, it is just classifying the person, the image is at which stage of diabetic retinopathy. Now let's do detection. So for that, let's open, under diabetic retinopathy, click on detection. Click on choose file. Get back. Open detection folder. So now let's upload the first one. And now what will happen is the image, similar to classification here also, it will be processed at the backend. It will be fed to the train model and then train model will be giving the prediction. So here you can observe, right? Mild stage has been detected and a blue color bounding box is drawn around the area where that nerves have been affected. You can observe, right? A bounding box is drawn around it and given the label that mild with a 0.75 probability score. So your probability score is nothing but it's the confidence level that how accurate the detection is. Now get back. Click on choose file to upload some more. So now let's upload this one. Let's upload this one. And here we got the detection. So here it is at moderate stage and a bounding box is drawn around the retina and it has given us 0.61 probability score. Now let us upload some more. So let's upload this image. Here also this image is at moderate stage. Now let's upload one more. Click on choose file. So now let's upload this one. Here you can observe, right, there is no diabetic retinopathy. So here the person has no diabetic retinopathy. Let's upload this one. So here you can observe that there is no diabetic retinopathy has been detected. Let us upload some more. Click on choose file. Let's upload this one. So here also no diabetic retinopathy has been detected. So now let's upload this one. So here you can observe, right, moderate stage has been detected. In this way, you can try with all the cases. Now let's check with the graphs. Click on graph. So here we have the graphs. So the first graph is a classification. First we have graphs of classification. So here on x-axis we have accuracy score, and on y-axis we have all the algorithms that are trained for classification purpose. And this is the precision score, this is recall score, this is FN score, and here we have detection graph. So this is the precision recall curve graph, this is precision confidence curve graph, this is the recall curve graph, and this is the FN confidence curve graph, this is the confusion matrix, and here we have precision, recall, and MAP. Mean average precision, recall, and precision are the evaluation metrics used for evaluating the detection models, and accuracy, precision, recall, and FN score are the evaluation metrics used for evaluating the classification models. Now click on sign out. In this way, just by uploading images to the application, it will do the detection and also classification. If you choose classification, it will just classify it is at which stage, and if you choose detection, it will identify at which part the nerve cells are being affected, and it will draw a bounding box, and it will detect which stage that person is at, whether it is severe stage, mild stage, or at any other stage. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.